Hello, I'm Marcela Ovando-Tellez. I'm working in neuroscience of creativity, and I will show you how creative abilities are related to the organization of the concepts in memory. So, what is creativity? Creativity can be defined as the ability to form new combinations by associating remote elements. For example, for three concepts that seem to be unrelated, such as liberty, artwork, and motionless, the more creative people will be able to find a word remotely associated to them, such as a statue. There is an associative theory of creativity that hypothesizes that creative abilities partially depend on the organization of semantic associations in memory. And we can represent these organizations using semantic networks in which the concepts are the nodes that are connected to each other by links. One of our collaborators developed a method to build semantic networks and to quantify the topology of their connections using several graph metrics. I will focus in the main metrics that are clustering coefficients that describe the density of the connections and the average sorted path length and diameter that are two metrics describing how spread out is the network. Most of the studies using semantic network have been focused on semantic memory, but not creativity, except for some studies carried out by our collaborators. In this project, we use their approach to investigate the properties of semantic networks and relate them to creative abilities at the individual level. So the first step was to build the individual semantic networks, and for this purpose, we developed an associative judgment task in which the participants rated the relationship between several pairs of words. To select the words, we control their linguistic properties and the proportion of the semantic distance between them. The trials we used for this task were all the possible pairs of words combining the 35 selected words, and the related ratings given by 21 participants were used to estimate their individual semantic networks. To quantify their creative abilities, the participants completed a set of validated creativity tasks, the alternative uses task, in which they were asked to give as many alternative uses as possible for three different elements, and we rated the originality of their responses as a measure of creativity, and a questionnaire of creative activities and achievement in different domains, and the total scores in the different items were used as a measure of creativity. Then, we correlated the different scores in the task with the different graph metrics obtained from their individual semantic networks. And as results, we can observe that the originality in the alternative use task was correlated with the clustering coefficient, showing that high creative individuals have a more connected semantic network compared to low creative individuals. In addition, the average sorted path length and diameter was also correlated with this task, showing that high creative individuals have a less spread out semantic network compared to low creative ones. The graph below shows the correlation between this task and the diameter, but the correlation with the average sorted path length had the same pattern. In addition, this last correlation was also observed with the questionnaire of creativity. In this illustration of individuals' semantic network, we can observe that a low creative individual has a less connected and more spread out semantic network compared to a high creative individual. And these results support a close relationship between an individual's semantic memory organization and their creative abilities, and importantly, they support and extend previous results. The next steps in this project is to explore how brain connectivity is able to explain the associative mechanism of creative abilities, measuring the brain activity with the fMRI during the associative judgment task. Thank you very much.